Okay, so we're going to take a look at yet another tracker lab. This one is going to deal with looking at the energy while something actually happens. So here's what we're going to do. I'm going to open up Tracker, and we're going to import the video that we're going to use for this one. Now, what I did is in class, or in a recording that I did, I made a small, for want of a better term, roller coaster using one of our low friction carts. Now, as a brief reminder, it's not a no friction cart, it's a low friction cart. So here's what I'm going to do. I'm going to do File, Import, Video. Now, it didn't start off in the right folder. That's okay. If you're using my computer, go to the desktop, go to Tracker Labs. TLab007c is what we're working with, and the MP4. MP4 is a video file. So this is the video that we're going to work with. And it'll take a minute for it to load in, but what we're going to do is we're going to have Tracker collect some data for us from this video, and we're going to use that data to make calculations about the energy. Because to my knowledge, Tracker doesn't record the energy itself. It may be programmed to calculate that up, but it's going to calculate it up using the same thing that we're going to do. And I'd rather you get a little more familiar with how we're going to use the data. We know that Tracker does measurements of our position, and we'll actually use that and the time data to actually find the speeds involved. So I could watch this, but it takes quite a while because it's in slow motion. But we've got a hill here that goes down to a flat level, and then it goes flying off a cliff. And so by it, I mean a low friction cart with a bright orange ball on it. So I set it there, and at about, frame, we're probably going to need this. Let's say frame 9, too far. My computer's memory is a little low. That's okay. I'm going to go 894, 900. There we go. I'm just now letting go of it. I can see it starting to move there. That's at about frame 915 or so. We know it starts moving. And then I'll just click through this. We can see that it rolls down the hill there, keeps rolling, keeps going, levels out, kind of goes over a little bump there, and then keeps going straight, and then goes flying off the cliff. Now, we're going to follow it to partway through its time in the air. We don't need to follow all the way to the ground. In fact, right about here, the car is starting to twist a little bit. The camera may not be able to track it, or I should say Tracker may not be able to track it as well. So we started at frame 915, and it looks like we're going to end at frame 1030. So I'm going to go up here, and I'm going to say begin at frame 915 and end at 1030. There we go. Now we've got it where I want it. Okay, I'm going to teach it how long a meter is. So our calibration stick, new calibration stick. I'm going to drag this over to one end of the meter stick that I've got in the frame here, then the other end here. And remember, we want it in meters, not centimeters, so this is 1 meter. Great, I can hide that. It's still there, but it's just out of my way. Let's set up a coordinate system. So here's what I'm going to do. I'm going to try and make y equals 0 at my lowest point, which is at the very end here, which is fine. And I'm going to put x equals 0 somewhere towards the beginning, back over here. Let's see where it ends up. I drag this back over. It looks like we've got x equals 0 pretty close to right there. That looks good. And we've got y equals 0 at the end over here. That looks pretty good too. You don't have to do it this way. You can set your coordinate axis pretty much anywhere you want, but this is going to get something much closer to how we would solve it in class. Okay, I've set up my coordinate system. I'm going to get rid of, or I'm going to hide it, I should say. It's still there, but I'm going to hide it. I'm going to do create a track. And we're going to hold down Control and Shift because we don't want to click on 115 frames ourselves. Now, there is an upside to doing that. It would take a while, but it would probably clean our data up a lot more. And I'll show you here in a little bit, but that's okay. We're going to do Auto Track because that's what we're going to do. Hold down Control and Shift, and we're going to go through, and I like to select the point where the blue meets the orange on the cart. So I'm going to select that, and you can see here in our template, it's got a lot of orange and a little bit of blue. So here's what I'm going to do. I'm going to drag this down. I click Search, and I watch it as the track follows the ball down the hill. And we can see here that there's a little bit of fluctuation here at the beginning. Auto track, I originally had it where it was on the middle part of the ball. Now it's kind of gone to the back. That's okay, but we should keep that in mind whenever we look at our data, that it's not always getting the exact same spot. That's okay. It seems to be tracking pretty well. We're not off on the moon somewhere. It seems to be following it. And we keep going, keep going. And there we go. Didn't have any strange tracks. If it got off track, no pun intended, if it started tracking something else, you can always clear this and do a different track. Try clicking on a different spot so that it gets good contrast. You can see that it did a pretty good job of following the ball. It's no longer in the middle of it, but it did do a pretty good job of following exactly where we wanted. Now here's where we're going to talk about what data we want to collect. Now tracker will record by default the time. The time is coming from the frame setting, the frame rate from our recording. I've got this camera set to about 119 frames per second, so they take 1 second, divide it by the number of frames, and that's how much time is in each of the frames. Now that's assuming my camera is very consistent. Don't know about that, might be a little bit off, but still a pretty good result. And then it can track the X position and the Y position based on where it puts each of these dots. There's additional stuff that it can do. It's programmed with the kinematic equations that we work with, and it can do things like finding the speed. And it does that by looking at the position before and the position after our data point and looks at the time that has elapsed, and it goes through and it can find the speed. Now here's the thing, we need some data so that we can try and find our energy values. Well, we want to look at kinetic energy, because this thing is moving during the problem, and we want to look at gravitational potential energy. So for kinetic energy, we need 1/2 mv squared. Well, I measured the mass of the cart and the ball together using a scale, a balance. And I can tell you that the mass is 100 grams. It's actually 101, but we'll call it 100 grams. And so we've got the mass, so we need the speed. So I'm going to click on Table, and Tracker can find the magnitude of the velocity, which is our speed. It does that by finding the velocity in the y component and the x component and using Pythagorean theorem. Check back on the lab that we did with circular motion, and you can see through that. All right, so we've got our speed, which is something we need. For the gravitational potential energy, we need the mass, mgh. So we need mass, we need the gravitational acceleration, well, it's near the Earth, so it's probably about 9.81. And we need the y-coordinate, how high up the thing is, so we need y. But we do not need x. So I'm going to go ahead and unclick that because we don't need it. So with this data, we have pretty much everything that we need. So I'm going to select all of these, and I'm going to copy them. You can right-click and select copy, or you can do Control-C. Let's go over to Excel so that we can do work on these. All right, here we go. I'm going to check the recording real quick. I'm going to paste this in. I'm going to check my recording, and we'll be back with you. Okay, everything's looking good. Just wanted to check the recording there. Here we are. I've just pasted my data in. We've got the time, we've got the y coordinate, so how high up the thing is, and we've got the speed at each of the points, at least that we can calculate up. Now, because Tracker uses the data from the position before and the position after, that's how it finds the speed. It cannot find one for the very first one because it has no data from before that. By the same token, it also cannot find one for the last one because it has no data point after that. So in case you wondered why when you ask for the speed, it doesn't do the very first one or the very last one, it can't based on how it's calculating the speeds. All right. So for that, we're basically going to we're going to exclude the very first data point and the very last data point so that we can get a clear value there. Along the top, I'm going to put a little bit of information in. I'm going to put in the mass of the object in kilograms, and I'm going to put in a different cell just the number so I can work with that. It's 0.1, or you could do 0.101 if you'd prefer, but I'm just going to go with 100 grams. All right? And then we also need g, the acceleration due to gravity, which is measured in meters per second squared. There we go. And that one is 9.81 near the surface of the Earth. Pardon me. So we're going to find the kinetic energy. I mentioned that's what we're going to look for. I'm going to mark it as KE. and that's measured in joules. Okay, I'm going to skip the very first one, but for the kinetic energy, I'm going to need 1/2, so I'm going to do 0.5, that's 1/2, times our mass times v squared. So I'm going to do v, hold down shift and hit 6, that's the up caret, and then, oops, not 6, 2 squared. There we go. Here is our kinetic energy. Now I'm going to drag this down a little bit, and we can see almost immediately it starts freaking out. Well, why? Oh, it moved down with the speed, which is what I want, but the mass needs to stay the same. Now, we've talked about this before, I believe, but I'm going to come up here to the mass, and I don't want Excel to change that one, so I'm going to put $signs in. $signs are the message to Excel to not change that location. And so we can see the numbers look good. It's using the speed here, but it's staying with the same mass. Great, that's exactly what I need. All right, over here, let's go ahead and make the potential energy from gravity. I'm going to measure that in joules, and then we can get that by doing m, our mass, times g, times y, our height, our y-coordinate. Now remember, we don't want the mass to change, and we also don't want the acceleration due to gravity to change. The only thing we want to change is the y-coordinate. So I'm going to drag this down. One of the reasons why I did it this way is now I can take both of these columns and I can drag them all the way down together. I just highlight both of them. There we go. So now I've got my kinetic energy and my gravitational potential energy. Here's the last thing that I'm going to ask you all to find. I want you to find your total mechanical energy. So I'm just going to call that E, but it's, as a reminder, our mechanical energy is adding our kinetic and our potentials together. So what I'm going to do is I'm going to say that this equals my kinetic plus my potential. And then I'm just going to drag this all the way down. There we go. All right, there's one final thing that I'm going to do before we actually go in to do the graphing part of this. This is just to make it look a little nicer because we've got some numbers that are kind of hard to see. I'm going to come up here to the left. I'm going to select all of the cells by clicking in between the 1 and the A, right up there. I'm going to go down here to Format Cells. Take just a moment. Come on, computer. I believe in you. Number. Let's go to 2 decimal places. That's going to change how it presents the data, but it will not change the data. That looks a lot nicer. We start off with 0 joules of kinetic energy. We start off with basically 1 joule of gravitational potential, and now we end up with 1 joule of total energy. And so we're going to see what happens. We're going to make a graph to see what happens to the energy as time goes on. Insert. We're going to go to my favorite graph, which is a scatter plot. Here's what I want to do. Let's go ahead and do one that's a little bit more smooth, nice smooth curves. We don't need to see the individual dots on each of them. Now, you can use different setups if you want, but this one might be a good one for what we're looking at. So I'm going to do right-click. I'm going to go to Select Data, and I'm going to add a data series. This series we're going to call Kinetic Energy, and we're going to use, for our x values, I want the kinetic energy versus the time. So I'm going to, for my horizontal axis, I'm going to put in the time. And then for my y values, I want the kinetic energy. So this is going to get kinetic energy, what happens to it over time. It'll take just a moment. This is not the most powerful computer. Okay, so we start off with 0 kinetic energy. It climbs up, levels out for a little bit, and then starts climbing up again, almost to 1 full joule. Now, one thing that I want to talk about with the kinetic energy real quick is we don't have a nice smooth curve. We've got bumps that go up and down. Now, part of that is based off of, well, how well we can take a measurement. Now, we're relying on Tracker and its ability to keep track of exactly where the thing is and calculate up what we need. Well, as we saw, Tracker doesn't always click on the exact same spot each time, and so as a result, it might choose the front of the ball at one point and middle of the ball or back of the ball at another point, and because of that, the computer thinks that the ball has done a lot more moving than it actually has. And so it'll say, oh, it moved really quick there. But then right after that, it selects back to its original spot, and it says, oh, well, it moved much slower there. In reality, the ball was moving at kind of a constant rate, and while we have ups and downs, the average of those is kind of what we're actually seeing. So we'd have a nice smooth curve that describes what we're looking at. This is what we've been talking about the entire year, about precision of measurement. In physics, when things are moving, a lot of times it's really hard to get a clear, precise measurement every single moment. And that's why I've been teaching you the importance of you don't rely on just one data point. You look at all of them together so you can see what's actually happening there. Even if you can't make a very clear measurement yourself. I don't think the speed is right here or right here, but I bet the overall trend here shows me what's happening with my kinetic energy. Great. So now that that small but necessary aside is done, let's go back to select data. I'm going to add another data series. We're going to graph multiple things on this one graph. This series is going to be our potential energy from gravity. So our x values, we're going to see what it does with time. So I'm going to select my time coordinates. Great. And then my y values, I want the gravitational potential energy. So I'm going to put that in. Great. All right. Slowly now, computer. There we go. We can see as the kinetic energy increases here, we got it from the gravitational potential energy. They're doing the opposite. We lose gravitational potential energy and gain kinetic energy. And the gravitational potential energy levels out about here. The kinetic energy levels out about there. And then the gravitational potential energy continues to decrease and the kinetic energy goes up. We start off with about 1 joule total in our gravitational potential energy and for our total energy because we have pretty much no kinetic energy. And at the end, we end up with almost no gravitational potential energy and almost 1 complete joule in kinetic energy. So this is showing us conservation of energy. The final thing that I'm going to have you do, select data, is we're going to double check that what happens to the total energy. All of it put together, which was that last one that we did. So we're going to do E for the total energy. We're going to see what it does over time. So I'm going to select time as my x coordinates. And then I'm going to select, for my y coordinates, the energy. In this case, this is my total mechanical energy. And we can see what the total energy looks like over time. And we can see here, we see a little bit of a dip. Kind of goes back up, which is a little strange, but we can see a lot of this comes down to it has the same ups and downs that our kinetic energy had. In fact, if we had a cleaner measurement of this, we would end up with something that looks a lot more like pretty much a straight line right at about 1 joule. This shows us energy conservation. So the weird shape of it, if you'll notice, it mimics the weird shape that we have on the kinetic energy. And we know that our kinetic energy is not a perfect measurement. We know why it's that way, but we also know that it's a pretty good measurement overall if we look at the trend. Our kinetic energy is going up, stays even about here, and increases back over here. All right, a couple things to finish up. First off, with us changing the scale that I did a moment ago to make the numbers look nicer, the scale on our graph is actually looking pretty good too. So that saves us a little bit of trouble there. I'm going to go to Chart Tools, Chart Design, Add Chart Element. We're going to go with Axis Titles. We're going to add a title to the horizontal axis. This one is time in seconds. And then we're going to add an axis title to the vertical. This one is energy in joules. And then finally, let's put an actual title of the chart. So chart title, above chart, here we go. And we're going to go Sanchez's energy versus time graph. And that'll be perfectly fine. Now we know what we're actually graphing here. It's an energy versus time. Our big problem is this. We have 3 different types of energy that are graphed. So there's one more thing I want you to add. Add chart element. And depending on what version you're using, it may even come up with this. We're looking for a legend. Let's put it on the right. There we go. That tells me that the kinetic energy is in blue, my gravitational potential energy is in orange, and my total energy is in gray. Though I'll be completely honest, I'll probably be able to understand what this is because I know what you're doing, but in case you're using this down the road, we can get a clear idea, or if you were showing someone new this, we can get a clear idea of exactly what these are. The kinetic energy is increasing as the gravitational potential energy decreases, and our total energy stays about the same. So this is pretty much the graph that I'd like to see. All right. Okay, so this is a supplemental one. I do I think what we get from the graph for the energy tracker lab is pretty good, but I'm still kind of bothered by how much noise there is in the kinetic energy, in our velocity, our speed specifically. And so we had a bunch of points where it went up and it went down. So here's what we're going to do. I'm going to try and reduce that some. Now I'm going to try and balance it. We have a point mass. Here's what I just finished putting together for what we were doing. I have a point mass that I tracked using auto track. And so, let's see, where did I have that? Track, mass A. Here's what I'm going to do. I'm actually going to, I should probably save this first. Save tab as. And I'm going to do this as Sanchez. Pardon me, that's fine. So I guess I don't have to delete the other one. Here's what I can do. I can do no, let's go ahead. I'll save it as a different file. The other reason that I'm going to do this is so I don't have to click on 115. I'm going to come back in here and we're going to do something a little bit different than we've done before. Step size. I always had you skip over that. Instead of going 1 frame at a time, what I'm going to have it do is go 5 frames at a time. So instead of doing 115 clicks, I'm going to do about 23. It means that it's going to increase by 5 frames instead of all the ones that we saw. Here's what I'm going to do. I'm going to do a new, in fact, let's get rid of the old track because I'd rather just not have to deal with it. So delete, there we go. Here's what I'm going to do. I'm going to go to create new track, point mass, and here's what I'm going to do. I am going to try and do this manually. I can't zoom in as much as I'd like. That's fine. So I'm going to hold down Shift, and here's what I'm going to do. Let's try and do this in a way that we can actually recreate this. What I'm going to do is I'm going to click on the front edge of the orange ball as best I can. There we go. So there's the first one. Now it proceeded from 915, frame 915, to frame 920. So I'm going to click on the front of it. That's fine. As we can see, it's starting to move a lot more because it's speeding up a lot, so it's moving much faster. Now from this, I can see I'm not doing a very good job because it's kind of going up and down. I'm going to try this one other way real quick. I should have tried this before doing the recording, but I want to see what this actually turns up to be. So point mass. I'm going to see if I can get something that's even more reproducible. So I'm going to go with basically the point right here on the edge of the orange ball between it and the sticker. That's probably going to be about the best that I'm going to be able to do. Maybe I should just do it on the sticker. I will try that in a minute if this starts acting weird. I'm afraid that I may not be able to see the sticker as it starts blurring a little bit, maybe with some motion. But I can kind of get an idea of where the middle in between it and the orange ball are in each of them. Now I could go through and I could click on all 115 frames, but I might get very good results if I do that. Let's see if this ends up cleaning it up some. Because right now, my going idea is one of the reasons why the speed is so up and down is because when the computer is trying to track it, it may jump around on the ball. So what I'd like to see is this. I'm going to go through and I'm going to see if I can consistently click on about the same point each time, if that's going to clean all of our data up a little bit better. Now, I'm not actually going to ask you all to do this, even though it might be something that you might consider doing. This is a way that we can go through and we can try and cut down on some of our experimental error. In other words, we can cut down on the data points being possibly off. Okay, so table, here we go. I'm going to get rid of the x values. I'm going to bring in the v values. Let's see what we've got for our speed. That's not bad. Now, one of the things that I'll point out, I'm going to copy these, I'm going to paste them over, and I'm going to create a new sheet here. I'm going to paste this in. Now, I don't have nearly as many data points as I used to, and that's both a good thing and a bad thing. I like having the additional data points. The problem is with all those data points, we saw that our kinetic energy kind of went up and down because the measurement was kind of all over the place. So here's what I'm going to do. I'm going to do kinetic energy, gravitational potential energy, and total energy yet again. I need to program this in, so we're going to do mass. I'm going to do this kind of quickly. It's 0.1. G is 9.81. You can check the other video to see exactly what I'm doing here, but we've got 0.5, that's 1/2, times our mass, times v squared. There we go. And I'm going to go back up here. I'm going to put my dollar signs in so that does not change. So here we go. Drag that down. Great. Gravitational potential energy, that's going to be mg y. Oops. I put in one too many multiplied by. C4. Yeah, I got that right. Okay. Never hurts to double check. I need to make certain that it does not move the mass or the acceleration due to gravity. It's going to keep those the same. And I'm going to drag these down. There we go. Now let's see what our graph looks like this time. Oh, and the total energy. Look at me, I'm bad at this. This plus this. Great. Drag this down. There we go. Just like before, I'm going to clean up the numbers a little bit. I'm going through kind of quickly here, but I'm just doing the same steps that I did in the previous one. Let's see if we've got all of that crazy up and down that we had with the other one. Here we go. Add, series name. This one is going to be our kinetic energy. Our x values are going to be the time right here. Now we don't have near as many data points as we did the other time, but that's okay. In this case, we've cut down on the computer jumping around. Let's see what we've got. Now, we've still got a little bit of up and down. It's not perfect, but you'll notice that we don't have those weird jumps up and down like we used to. So that's a big thing for us to take into account. It may be that what I said was more or less the case, that the computer was having some trouble with that. Let's see what the gravitational potential energy looks like. Add. Potential energy from gravity. X values, so we're going to go T. And we're going to go gravitational potential. Almost selected the Y. Great. We end up with a much prettier graph, although we've still got a little bit of wiggle room here. Don't know about that, but that's okay. And then here we go, select data. Let's see what the total energy looks like. Total energy, X. Now remember, all of these are still based off of our data points. This is us making the measurement. Now it may also not be perfect, but we don't expect it to be perfect. We're doing lab science here. So we can see that overall I do have a bit of a decrease here, but there's air resistance and friction that I'm totally not taking into account. And so, but we still get kind of an average that's a little bit less than the 1 joule. In this case, we've cut out a lot of that up and down noise, is how we would usually call it. Let's do one final thing. In fact, I'm going to move or copy. This is a trick that we've used before, create copy. And so the second one here, here's what I'm going to do. I'm going to create a second track. Let's see what happens when the computer tries to track it, but this time specifically when we are set to 5 frame increments. I'm going to put that there. Let's see if it will track. So it's doing more or less what I did just a moment ago. Let's hope that it can actually track it pretty clearly. Maybe we should be altering this on a regular basis. It had trouble tracking here. It's saying, hey, we're pretty close. It's hard for me to see because the red one's still in the way. I'm going to go ahead and click accept. That looks pretty good. I can see a little dot there. It looks like it's mostly following it. It's having, ooh, that one was a little bit off, but that's okay. We'll know at the end that it got a little weird. So, get rid of X, add our speed. Let's see what the computer ended up with when it did auto track. Maybe it does a better job if I don't have 1,000 data points for it to take a look at. It cleaned up quite a bit, just like mine did. Here, the nice thing about this is I can just paste this data in and it'll automatically update. Here at the end, I told you that it did act a little weird. I noticed that it jumped from one side of the ball to the other, which was what I was talking about with the individual tracks. So, one of the things that we might consider doing, now that we've got this information, is in the future, maybe set it up where we don't check every single individual frame, but instead do maybe 5-frame increments. So that way we still get plenty of data points. We've got 20 some odd data points, which is great, but we don't have near as much jutting around, and it might be a little bit easier for you. But something to take into account. I personally think that this one's a much better representation. That's the one where I manually clicked it. That being said, I'm not going to ask you to do that. You can still do the auto track, but I wanted to go ahead and do this so that you got an idea that there are ways that we could clean up all of this up and down. That's an effect of the computer, and it underscores what I talked about throughout the year, where we don't take one individual data point we get, we graph it so we can see the overall trend. We know that the kinetic energy is increasing as the potential energy is decreasing, and that's their relationship, and that we end up with a pretty much total constant energy. Now in real life, we're going to lose a little bit from it, and I leave it to you to figure out why. All right.